Hello everyone, I'm Alex Rojas and welcome back to my YouTube channel. Today I'll be talking about the Handiest measuring tool. This tool will allow you to estimate large distances. For example, how high is a mountain, or how many more kilometers do I have to walk before reaching a specific building, or how many hours do I have to wait before the next sunset, for example. So what is this amazing device that allows you to estimate those large distances? It is anything else but your own arm. The way it works is the following. If you stretch out your arm and you make a fist, your fist will be covering a specific angle, and this angle will be related to two quantities. So I'm gonna call this angle, let's say, theta, and it will be related to two quantities. One is the distance from my eye to my fist, which I call this R, and the width of my fist, which is D. Actually, the relation will be how they are related is the following. D is proportional to R. So the width of my fist is proportional to how far my fist is. And the constant of proportionality is this angle. So this is very nice. I will do it. I did the measurement for my arm and I got R equals to 60 centimeters. And I measure my fist and I got the diameter or the width of my fist equals to 10 centimeters. So if I grab these two numbers and I calculate for theta, I have that theta is equals to 10 centimeters divided by 60 centimeters. Well, the first thing that I notice is that these units cancel, so I don't have to worry about if I have to use the metric system. I can use inches if I want to. But so you can do it at any units, and this will give you, well, in my case it gave me 0.17 radians, right? This is the angular coverage of my fist. If I want to translate this into degrees, because I'm more familiar with those units, I say okay, 0.17 radians I have to multiply times 180 degrees divided by pi radians. Again, these two quantities or units cancel and I get everything in degrees, and this is approximately equal to 10 degrees. So now I know that my fist, if I stretch out my arm, is about 10 degrees in angular coverage. For example, if I go out and look at the moon and I see that my fist is completely eclipsing or covering the moon, I know that the moon has an angular span of 10 degrees. Well, now that I know I have this piece of information, let's go out and do some measurements. So imagine that I'm in Paris, I'm walking around and I see the Eiffel Tower very far, and I've been walking for 1 hour. I need to know how many more walking do I have, how much walking do I have to do. I have my little booklet that they gave me in the hotel, and the booklet told me that the Eiffel Tower is 324 meters in height. So this is going to be my D. And well, I grab my amazing tool, stretch out my arms, use my fist, and see what is the angular coverage of the Eiffel Tower. And I noticed that with only one fist is enough to cover the entire Eiffel Tower. Therefore, I know that this is 10 degrees because I already know that my fist is about 10 degrees, which in radians is 0.17 radians. Well, I know that D is equal to theta times R, but R is my unknown. Therefore, R is equals to D divided by theta, which is 324 meters divided by 0.17 radians, and this will give me approximately 2 kilometers. So I know that I still have to walk a couple of kilometers, and based on how fast I walk, I can estimate, I don't know, 50 more minutes that I have to walk. So it was that simple. Let's use another example. Let's imagine that I'm hiking and I see a very nice tall mountain that I would like to climb. And well, I know from my GPS that mountain, it is located about 10 kilometers away. So I'm from where my current location to the mountain is about 10 kilometers. And again, I stretch out my arm. I try to do a measurement of the angular coverage of this mountain, and this time I noticed that only one arm or one fist was not enough. I have to put one on top of the other one. So I have two fists, which is 20 degrees. This is 0.34 radians. And I need to know how high is my mountain. So D. In this case, D is equals to theta times R. Theta, as I said, is 0.34 and R is 10 kilometers. So this is simple to calculate. The height of the mountain I'm estimating is going to be 3.4 kilometers. So if I'm planning to climb this up, I will be looking into climbing a 3.4 kilometer mountain. So that's also really nice. Now let's see the last example. Well, in this example, this has nothing to do to estimate distances. It's basically to estimate time. And you can do this with the sun or the moon or any star. You can actually go out and try to figure it out how many hours have gone before after you take a measurement, and then you take another one, and you will see that this will give you a good estimate of the hour, especially for people that are near the equator. The closest the equator, the better you can do this estimate. Now, how does it work? Well, any celestial object it seems from an Earth observer that is going around the Earth 1 revolution in 24 hours, so 360 degrees in 24 hours. We know very well that nothing is moving around the Earth except, well, the moon is going around the Earth, but no celestial object, no star is going around Earth. It's the Earth that is rotating. But this is from the perspective of a person on Earth. This is equivalent to say, okay, everything is going around us 360 degrees every 24 hours, which is equivalent to say that it is about 15 degrees every hour. So now I know that everything on the sky apparently moves 15 degrees every single hour. So for example, if the sun is out and is near the horizon, and I want to predict how many more hours do I have to wait before seeing the sun right here, a sunset, well, I again stretch out my arm, do a measurement of this angular coverage. So from here to where the sun is, and to the horizon where I'm expecting it to be at sunset, and this angle here I can measure using my fist, my handy tool. And in this case, let's assume I have to use 3 fists. I have to put one and then on top of the other one, and then I have to switch this fist and put it on top of the other one. If I'm doing it 3 times, that it will be equivalent to 30 degrees, because each one of them measures 10 degrees. And if it is 10 degrees and I know the sun is moving 15 degrees per hour, voila, I know that I have to wait 2 hours to see the sunset. So these are the 3 examples that I have. Now I have a question. Let me know if you have any other examples that we can do. You can estimate, for example, how far is the moon. If you Google the diameter of the moon and you stretch out your fist and measure the angular coverage of the moon, how wide is the moon in terms of angles, you can do an estimation of the distance, how far it is the Earth from the Earth's surface to the moon. And then you go again to Google and compare if your estimation was correct or was really, really far off. Well, I hope you liked the video. I'm expecting to see some comments and questions. So thank you for watching. Bye.